Hey warriors, in this video I'm going to show you guys how to do a rotation. So a rotation is a rigid motion transformation that turns a figure about a fixed point, which we call the center of rotation, through a given angle. So our main points is that there's a center of rotation, that's what we're rotating it around, and it goes a certain angle, like it needs to turn a certain angle, okay? So that's very important. But if you look, it says a rigid motion transformation. We know that rigid motion means that it is going to be a congruent figure. It is being turned, yes, but the sides are still the exact same length, the angles are still the same, nothing has changed on the figure itself except that it's being turned. Like take this pair of scissors for example, okay? Now if I turn these scissors, they're still the same scissors, right? They didn't get bigger, they didn't get smaller, the pattern didn't change, like the only thing that happened was that it just turned, okay? So that's a rotation. All right, so let's look at a graph. Actually, let's look at a question first. So our first question is gonna say, rotate point A 90 degrees counterclockwise around 0, 0. Okay, so we wanna rotate it 90 degrees counterclockwise. First off, I want you guys to remember what a 90-degree angle looks like. Hopefully you remember it's like this. It should, like the corner of your desk, the corner of a piece of paper. A perfect square has all 90-degree angles. This is one you should be the most familiar with. And the next thing you need to remember is that it says counterclockwise. So I want to specify really quick. If I'm looking at a clock, counterclockwise goes this way. This is counterclockwise. Clockwise goes this way. Okay? Clockwise. So I want to go counterclockwise. All right, so now let's look at our graph. It says we want to rotate, this is point A right here, sorry. It says let's rotate point A 90 degrees counterclockwise. Okay, so I taught my class to use a hook to rotate this. So that's what we're gonna do. Again, we are going around the origin. So the origin is 0, 0. So the first thing I do is I go along my x-axis and I draw a line that would line up with point A. So I'm going to do it in this orange color. So it looks like I went over 7. Now I'm just going to take that line alone and I'm going to turn that or rotate that line 90 degrees counterclockwise. So I'm first going to draw. Counterclockwise means this way, so I remember. So I'm going to take that line, I'm going to go 90 degrees counterclockwise. Most of you can probably see that it would just go up 7. Did you guys see how I did that? Because it was over 7, I rotated it 90 degree counterclockwise, gave me a perfect 90-degree angle, and now I went up 7, okay? And the next thing you can see is that I'm not at my point yet, so I'm going to draw my hook. Now my hook tells me to go 3. If I took this and I turned that 90 degrees, it would tell me to go 3 this way. So my rotation of that point, 90 degrees counterclockwise, would put it right here. Okay, so I'm going to label that one A prime. A prime. So that's one way to do it, okay? I just drew a hook to show me. I went over 7, I rotated that 90 degrees, up 7, left 3. Okay, that's A prime. Now I'm going to hurry and write my coordinates for you guys. So over here it was 7, positive 3, and this one is now negative 3, 7. So that's kind of interesting. Something you might notice about that, if we're looking at the coordinates themselves, my x and my y, like the digits themselves are the same. Do you see how I have a 3 and a 7 on both of them? Like in this one I have a 7, 3, this one I have negative 3, 7, but do you see how the digits are kind of the same? When I rotate something 90 degrees, the general rule you can remember, and it only works if it's around the origin, just so you know, I take my x and y and I flip them. So my y value would come first, my x value would come second, and I change the sign of my original y. So in this case, my original y was a 3, so I made it a negative 3. If it started out a negative 3, it would go to a positive 3. So that's kind of interesting, okay? I rotated it around the origin, I just made my y value change signs. Cool. Okay, now let's do it 180 degrees because my next question asks me to rotate the figure, or point A, says rotate point A 180 degrees around the origin. You might notice on this one, it didn't specify counterclockwise or clockwise. And the reason for that being is 180 degrees is a straight line, right? It's two 90s put together, so it's just a straight line. And I can get to that by going counterclockwise or clockwise, and it doesn't matter. If I go counterclockwise, I'd be right there, right? If I went clockwise, I'd go right there. Do you see how I ended up at the same point? So it doesn't matter which way you do it. You could go counterclockwise or clockwise. Okay? All right, so we're going to take it and we're going to do that. I'm going to use the hook again. So my hook, I would go over 7. I want to take that and I want to make that a 180 degree angle, which means I need a straight line. So I'm going to go in the opposite direction 7. So now I went to -7. Okay? And this time, on this one, I went up 3. So on this one, I would just go down 3. I kind of just did it in reverse. That's like all I did on that one. So my new point would be right there. And I'm going to label my coordinates on this one. This is now a double prime. And my coordinates are -7, -3. If I compare those with my original, you might notice that the value stayed the same, but they changed signs. So the rule you can remember with that one, when I rotate something 180 degrees around the origin, I keep my X and my Y, and they just change signs. Cool, that's all they did. Okay, now if you're like, I'm not sure if I did it right, that's totally fine, I get that. There's a trick you can do that will show you if you did it right. You can draw a line from your original to your origin, which was 0, 0, or to your center of rotation, which is my origin, and then to my point that I rotated, so my final point, and it should make the angle that it tells me. So I'm going to do this in blue so you guys can see it. So from my center of dilation, which is 0, 0, to my new point, and then from my center of dilation to my original point, that is a 90 degree angle. You guys see that? So I did that correctly. Now we're going to do the same thing from our 180. So from our original to our center of dilation, we should be able to draw a straight line that connects all 3. Do you guys see that straight line? That shows me that that angle is 180. So I did that one correct as well. So that's just a way to check yourself if you're a little bit confused. And again, this is a rotation of 90 and 180. The reason I showed you guys those two are because those are the only two that we really focus on at our school in 8th grade, is 90 and 180. So that's the rotation around the origin.